Students, today we're doing class 7, chapter 2, motion, part 5, and we're discussing about mass and weight. Mass, as you know, is defined as the amount of matter contained in a body. It is a constant quantity, that means it does not change, and it does not change with place or direction. Now, for example, this duster, it's a body and it contains matter, and therefore it has got mass. It is a constant quantity, which means that the mass of this does not change whether I keep it here or whether I keep it on the table or whether I take it outside. It will not change. And it does not change with place or direction. That means whether I keep this here in India or whether I keep this in another country of the world, this mass is not going to change. Whether I take it to space also, it's not going to change either. Now, for measurement, we have the SI units, standard international units, and we measure in kilograms. The symbol for kilogram is small k and small g, kg. And to measure smaller units of mass, we use subunits. The smaller subunit is gram. We use the symbol small g to indicate that, and the smaller unit of gram is milligram, which we use the symbol mg. To measure mass, we can use any one of the following devices depending on the accuracy of the measurement. The first one is a beam balance. A beam balance is simply a beam which is balanced at its center of gravity, and on the two ends we have suspension strings, and we have got pans on both the sides. So on one side we normally place a standard weight, a standard mass, that is in this case let's say 1 kilogram mass, and this causes this balance, the beam balance, to tilt to one side because this one is now heavier. So this will tilt upwards, and what we do is to bring it to equilibrium. Whatever we are weighing, we keep on adding on the other side till this time the beam is horizontal again. There is a small pointer here which indicates when it's pointing vertically upwards perfectly. So at the time this bar is horizontal, and that indicates that whatever mass that we have placed here is equal to the mass on the other side. So this is what a physical balance looks like and what it does. This is normally used by shopkeepers for measuring weight of the items that you want to buy, or the mass of the items that you want to buy. Next is a physical balance. A physical balance looks similar to a beam balance, but in this case it is kept in a laboratory and it is kept in a glass box. It's got a beam, it's got a bar here, and it's got a pans like this. It's got a pointer in the middle here. It's got a knob which you can turn to raise this pans up, and this is a far more accurate device for measuring mass. And it is kept in a glass box. It's because so that the movement of air does not disturb the beam, the balance inside, causing it to give error in the reading. So that is a physical balance. Nowadays we have electronic weighing machines. Is basically a flat device which has got a place on the top to keep the item that you're weighing, and on the front we have a LCD panel in which it gives the reading directly as to what is the weight of the object placed here. So let's say we place an object there, and let's say this is the place where it shows the display, and you can read directly as to what the mass of the object is. So this is about mass. Next, let us discuss about weight. By definition, weight, it is the force with which a body is attracted by the earth towards its center. So let's say this is the earth and this is the center of the earth, and let's say you have a body. This body is going to experience a force of attraction due to the acceleration due to gravity, and this body is getting attracted towards the center of the earth. So the force by which this body is getting attracted to the center of the earth, that we call the weight. So weight is basically a force. So since for the SI units, since weight is a type of force and force is measured in newtons, so weight is also measured in Newton. SI unit of weight is also in Newton, and while writing we write in small n Newton, Newton, whereas when you write in a symbol we write it as capital N. Now weight can also be expressed alternatively in kilogram force. So this is written as kg and a symbol F, kilogram force, and the subunit of kilogram force is gram force, which we can write as GF. Now what does this kilogram force and force mean? It means that in the case of 1 kilogram force, if we have an object which is weighing 1 kilogram and this is being attracted by the gravitational force of the earth, the force with which this 1 kilogram force is attracted by the earth towards the center, that force is called 1 kilogram force. So in this case, this force is equivalent to its weight. Similarly, in the case of gram force, 1 gram force would means the force by which the acceleration due to gravity attracts a weight of attracts mass of 1 gram. Now between kilogram force and Newton there is a relationship which you need to remember whenever you are doing conversions. So by definition 1 kilogram force is equivalent to 9.8 newtons, and we approximately take that as 10 newtons for ease of calculation. So you need to remember this. 1 kilogram force is equal to 9.8 newtons, approximately we take that as 10 newtons. Now for the devices for measuring weight, we have a device called spring balance. So basically, as the word says, we have a coiled spring to which we have a hook, and in this hook we attach the item that we want to weigh, and as a result of the attaching the weight, the spring stretches. So essentially we have a pointer attached to the spring, and this pointer runs along a graduated scale. So and this entire thing is enclosed in a box, so with the hook coming out. So as you place the weight at the bottom, this causes the spring to stretch and the pointer to move down, and the pointer will point exactly to the weight weight of this object here. So the spring balance it's got a ring on top for holding, it's got a spring inside, it's got a pointer, it's got a scale, and it's got a hook at the bottom where you can attach the weight. As you attach the weight, the spring stretches, it causes the pointer to move down, and this pointer will point on the scale, and from the scale you can get a direct reading as to what is the weight of the object that you have attached. Now once you remove the weight, the spring will again retract and will come back to its zero position. So when nothing is attached, no weight is attached, it'll be in a zero position, and as you attach a weight, it'll get stretched and it'll move downwards, and it'll let you know exactly what is the weight of the object. So now that we have learned about mass and weight, let us learn about the differences between mass and weight. So let me draw a table in which I will write mass on the left and the weight on the right. So we'll just discuss a few differences. The first one is the definition. This is the amount of matter contained in a body, whereas in the case of weight, it is the force with which a body is attracted by the earth. So this, as you know, is the definition by itself. Mass is constant and does not change, is one of the properties. In this case, weight changes as it depends on gravity. So you have, because your body and you have mass, so you have a certain weight because you are being attracted by the earth's gravity, and as you leave the earth's surface and you grow higher, the gravity becomes less and you will weigh less, and as you gradually go into space, there is no gravity, so your weight will become zero. You will be weightless and you will be floating about, whereas your mass in space itself will not change, whereas your weight will become zero because there is no gravity there. Mass can never be zero, whereas weight, since it depends on gravity, weight can be zero. Now how this can be zero? Where the force of gravity is zero, weight will be zero because weight depends on gravity. The SI unit is kilogram, whereas in this case SI unit is Newton. And the last one is the device used for measurement. In this case we use a beam balance or physical balance to measure it, whereas in this case we use a device called spring balance to measure the weight. So these are the differences between mass and weight. It's also given in a copy. Thank you.